So I just want to talk about three methods for solving some quadratics, just trying to recognize them in a certain form and then dealing with them. In this first form, I'm going to call the c equals 0 form. Notice that my constant here is 0. So looking at this, I'm going to see what I can factor out of that first part. And I notice that a 5 goes into both of these and an x goes into both of these. So I'm going to factor out a 5x. So let me see 5x, and if I divide this this by 5x, I'm left with a 2x minus, and if I divide this by 5x, I'm just left with a 5 equals 0. Now this is in factored form. I have these two things multiplied together that equal 0. That means that this equals 0, so that happens when x is 0. Or this equals 0. So let me see, 2x minus 5 equals 0. I can solve that by adding 5 to both sides, then dividing by 2. So that would be 5 halves. So there's my, if it's c equals 0, here's my way to solve that. The second form that I want to talk about would be what I'm going to call vertex form for now. And we will talk about why that's called vertex form. It's because you can read the vertex pretty much off of it. So I'll give you an example. 3 times x minus 7 squared equals 75. So notice what's going on here is I have 3 multiplied by this thing squared equals 75. What I want to do is take advantage of that I have this in this form, something squared. I want to eventually square root this. So first thing I'm going to do is divide by 3, get that out of the way. So if I divide both sides by 3, this divides out right here, and I have this x minus 7 squared equals 25. Now I can square root both sides, and if I do that, I want to know what squared gives me 25. And notice my answer could be positive 5 or negative 5. What's in here could be either positive or negative 5. Algebraically, the way that you deal with that is when you bring a square root into the problem, I bring a plus or minus with it, because you're finding each case that you could square to get that. So square root of 25 is 5, so now this is plus or minus 5. X minus 7 equals plus or minus 5. Add 7 to both sides. So you have 7 plus or minus 5. And 7 plus 5 is 12. 7 minus 5 is 2. Those are my two answers to that. Let me do one other thing with vertex form as well. Is this one worked out really nice because x squared is, 25 squared is 5. But it doesn't necessarily have to always happen. Like my original problem could have been 3 times x minus 7 squared equals, 30. I'm going to go through the same steps, divide both sides by that 3. X minus 7 squared equals 10. Now when I square root, I end up with plus or minus square root of 10. X minus 7. Add 7 to both sides. 7 plus or minus square root of 10. And there's my answers. They're just irrational. Still real, just irrational. All right, and then there's one more that I'd like to do, one more example. And that last example is really straightforward, and recognizing something in this form is going to save you a ton of work. So, clear up a little bit of space, and let's say I had something like 7 times x minus 3 times x plus 5 equals 0. So I'm going to call this factored form, because it's already factored, but factored form and equal to 0. That's important. If this wasn't equal to 0, this isn't going to work. I'd have to do a lot more work. So I could multiply this out, distribute the 7 in there, and then use quadratic formula. But why would I do that? It's already factored. It's already in a form where I can read the solutions right off of it. This times this times this is 0. So what makes this a 0? 3. What makes this a 0? Negative 5. There's my answers, just like that.